Hello everybody, welcome to the World of Control channel. I'm Mohammed, and in this video I want to continue our code that we wrote in the previous video to design a neural network model to identify our inverted pendulum dynamics. Okay, we will continue. We want to write the code that creates the MLP multi-layer perceptron neural network here. Okay, create neural network. Create neural network. Okay. First, we need to specify the number of the hidden layer size. Okay, I will say hidden layer size is equal to, for example, I think 5 layers for now is enough for now. And first we need to define a blank neural network model like net or net. I will call it net. Net is equal to the code that makes the blank neural network for us is fitnet, and our hidden layer size. This part of code is going to create a blank neural network that has 5 layers. If we need, for example, in each layer, for example, 10 neurons, we have to say 10 times hidden layer size. And if we run this, okay, now we can see that a network object is created in our workspace here. And if we run it, if we call it in the command window, we can see that we have a neural network that has a name, a user data, the number of inputs, a number of layers, and the number of weight elements. Because we have 5 layers and 10 neurons in each, we can see that we can have now 50 actually weights, because we have 50 neurons in our model. We can see that we have some features here that we will change to have our performance that we want and we need. Okay, and now we want to set up the vision of data for training and validation and testing. And let me make it bigger here, and we will see that we can actually specify different properties for our neural network here. So we can change the properties of our neural network with this command. For example, we will call the name of our network dot, and we can see that it has a lot of properties here that we can access to and actually change them. First of all, I want to change the divide function to divide rand here. This means that the divide data, our neural network will divide our data randomly to train itself randomly. The second property that I want to change is divide mode. Divide mode that I want to make it, for example, sample, and it means that we will divide up every sample. The next property that I want to change is, for example, divide param dot train ratio. For example, I want to have 70% of my data to be the train ratio data, and the second one is, for example, my test ratio that I want to be, for example, 15%, and the validation ratio, that is val ratio, it has to be 15%, and overall all of these will be 100% of our data. If you need any help in defining and setting these actually modes here, you can watch out the actually NN divide. You can see and watch out the NN divide here. Okay, the next step is select our training function. There are some training function like Levenberg, Marquardt, and such other training functions. We can say net dot divide is train FCN. That is our training function, and I want to actually set it as train LM, and this means that I want my neural network model to have the Levenberg-Marquardt training function to be the training function of my neural network. So it is Levenberg and Marquardt. Okay. Okay. The next thing that I want to specify is, first of all, if you need any help for the training functions, you can watch out the NN train help for NN train. You can write help for NN train, and you can access to all of the different training functions here. The next thing that I want to specify and set for my neural network is my performance function. There are some performance function that the MSE, mean square error, is the popular one in this case. So I will specify it as MSE for now. Net dot it's performance, I think. Train dot performance. function. Yes, performance function. I want to set it as MSE, and it is mean square error performance function. And if you need any help for um, for see other performance function, you can get help from NM Performance. Let's run it so far and see if there's any problem. Okay, if we call our function, our neural network here, we can see that our actually settings is what we wanted and what we specified in our code here. The next thing that I want to modify is my actually learning rate train param dot lr, that I want it to be for example 0.02. As default, I think it is 0.01. In different situations we can set it as different values, but in this situation I want it to be 0.02. The next thing I want to specify is my number of epochs. For example, I will begin with 100 epochs for now, and also we can specify other settings for our neural network, such as maximum fails or minimum gradients that we need, or maximum mu for our neural network that we want it to be achieved. But for now, I think it is enough for our neural network setting. You can see a lot of information about the neural network settings in the help of Matlab. But for now, it is enough, and we will actually train our neural network that we designed here with our data. Okay, the command that will train our neural network is train. Train has two outputs. Our trained net, and the another output that for now we do not need it and we do not speak about it. But if we do not need it, we can use this sign here that says that we do not need it. We will say train our empty net that we created here in line 23, and our inputs that is u underline modified, u underline modify, I think. Okay, u underline modify, and the third parameter that train need is our target. What is our target? What is to be predicted and identified? Actually, in this case, our target is theta. Theta is y here, so y, we will give it as y here. And now I will save the model, And now I think we are ready to run our code and um, actually train our neural network. Okay, let's train it. Uh, let's see what is the problem. It has an error here. Uh, Inputs and targets has different number of samples. Let's see how many, what is the size of our u underline modif. It is 10,001, 20, and what is y? It is 10,001. Number of samples. Oh, I forgot. The samples has to be uh, on the columns. So we need to transpose all of these um, inputs and outputs here so we can train our model. Always make sure that you set your inputs and outputs on the columns. The samples has to be on the columns. Okay, now we can run the simulation and we can see uh, actually window popping up, and we can see the process of learning here. It shows that the epochs, how many epochs has been run for training our network. We have some different actually information here, the number of epochs, elapsed time, the time that we are spending on training our neural network, our performance here. Our performance actually is our error that we want to minimize here, our gradient and our mu. Each of these actually variables has a target value that if um, each one of them achieved the goal and the target value, the process of training will terminate it and we will have our neural network trained here. Okay, let's see. Now we can see that we have a very small performance so far, so we can understand that our training process is doing very well. We have to wait until our training process finished. So far we achieved a very small performance that is really nice for us, so we are happy. Make sure that you choose appropriate values for each parameters here. If you see that our conditions has been satisfied and you do not need any more training, you can simply click on this icon here, stop training and finalize. And after some moment, the process of training will terminate it and the trained neural network model will show will show will show in the workspace. Okay, it has 25 more epochs, so we can wait. We can wait to see what we can do. Okay, 10 more epochs, so we can wait because I want to save it and I want to show you how to save our neural network model. Actually, we have some training algorithm information here that we can see. Okay, our epochs has been finished, and here we have some training plots that we can watch out if we need. We have our performance. If we click on it, we can see, we can watch our performance. Okay, we can see our performance here that is decreasing, and the best validation performance is this very small um, error here at epoch 100. We can see our regression figure here if we click on regression, and we can see our regression is very well here, and actually the fit, okay, um, it is not actually uh, activated in this situation. We can see if we uh, say our network, this network is our train network, so we can save it to our folder. The first variable has to be the name that we want to save our network with. So I will say net underscore pendulum identification, and the next variable has to be the net. The net has to be in double quotation mark, and I save it. And now in the current folder we can see uh, a matrix here, net underline pendulum identification, that is our trained data. In the next video I want to test our trained neural network and see if our neural network can identify our inverted pendulum dynamics. Make sure that you subscribe my channel. I will make a lot of videos about modeling and controlling and identifying different simple and complicated systems. Thank you very much.